Welcome everybody. So the last talk will be on database views. Now, as I mentioned in my introduction video, one of the things that we must encounter is the fact that when we're doing our visualizations, we can only point to one table itself, which can of course be a bit of a challenge if you're wanting to extract data from more than one table. Let's have a quick look at what that means. So when I go into my platform, I go down to data visualizations and go new, and maybe I'm just going to perhaps just do another simple list here. There's only the opportunity for me to actually select one table, and the one that we've been choosing at the moment, of course, is the incident table here. But I would also like to extract data as well from other tables. In other words, other related tables. In this case, it might be the service level agreement table, the same example that we've been using all along. I could, of course, go up into here and edit my columns. And from here, of course, I can see that there is dot walking available here. So I could come down and I could go down to the only one that really points to surface, and that's the one there. But notice it's actually it's not a reference field. If it is a reference field, then I can certainly jump off and I can actually extract fields from that related table, whatever it happens to be. But in this case, the SLA table is not a reference field, so I cannot extract data from that particular related table. I can certainly do it from many others. I can go down to the skills table and I can bring back fields from that, but not the SLA table. So that is a limitation of dot walking. But as I mentioned in my introduction, even if you do use dot walking to extract data from related tables, there is a cost and performance for this. So let's actually have a look at how we could actually solve this. Well, we actually solved this with a capability called database views here. Now I'm going to go in and find one that we're going to be working with. It's going to be based on the incident table. And it's actually called Incident SLA. Now, by the way, you should actually understand here that this one here was actually created by an application, by the way. Quite often, our applications, when you install them, they will install all sorts of things, including database views, report ranges, a whole bunch of stuff. So that's one that wasn't there baseline, but was added when the Spotlight application was installed. This one here is a baseline one. Now, to get it very clear here, what this is about, we are creating a virtual table, if you want to look at it that way. And the naming convention here we've chosen is the name of the first table underscore the name of the second table. You should never put spaces or special characters inside these types of namings. And it's a database view. Now down here we're actually labeling the tables, and you'll remember these from my previous demonstrations. So this is the incident table, and this is the task SLA table. And I'm wanting to extract data from both of these. Now there's actually quite interesting here. It is required that we create what's called variable prefixes for each table. The only rule is you cannot put special characters, you don't want to use uppercase either, and you don't want to be using spaces. So this is why task underscore SLA has been called task SLA table. Now, we then need to write what's called a where clause. Now let me explain how this works. Every table in ServiceNow, when it's created, whether you create it or not, has got a very special field in it called sys underscore ID. This table is what guarantees the uniqueness of records within that table, and it is absolutely essential when you are in a relational database management system, an RDBMS. They require every field to be unique within a particular table, so we can identify it by that unique value. Because some fields have got values, some records have got values that are in common, like names and addresses and stuff like that. So there must be at least one guaranteed unique field. Now ServiceNow creates these fields, whether you ask us to or not when you create a table, and we maintain that field. It's our job to maintain it. Now what happens is that when the actual task SLA table was developed, the developers actually pointed their table to the SysID field on the incident table, and that created a foreign key relationship between those two tables. And our system then uses those SysID foreign key relationships to maintain the integrity of the data. As a short example, by the way, if I just move sideways a little bit, if you had a customer table and you had a sales table, and you didn't have this technology, then what would happen is that programmers could possibly create their program to create sales records for customers that don't exist. Maybe they forgot in their code to check to see if that customer existed. Okay? Or the other issue could be is that the program could delete customers who've actually got records in the sales table, leaving orphan records behind. So how this all works in the real world, because in relational databases, is that we have this system where the database engine itself takes care of this. So the engine itself makes sure that even if the program says delete that customer, it won't if there are related records in the other table. Or conversely, if the program that the developer has written tries to put a sale into the sales table for a customer that doesn't exist, then the foreign key between the customer field and the SysID field will detect that that customer doesn't exist, and therefore that insertion of data will not happen. So, rather convoluted, isn't it? But it's quite nice to know that technology. Now, what this where clause does is that it goes to the first record in the incident table. And we use underscores. If you're a database person, you might think, oh, we use dots to eliminate between tables and fields. Well, we don't. This is JavaScript. And what it will do, on that first record, it will find that SysID value. I'm going to say that it jumps across to the task SLA table, and then it scans down the task field, looking to see if it can find a match. If it finds a match, because this is defined to be a common join equals, then it will bring back, that record will be inside our resultant data set. Okay? If there is no records in the task SLA table, then this incident record is not brought back, because we only want records where it has got corresponding records in the other table. Okay, so maybe no records come back for that incident, maybe more than one come back, maybe none come back. Once it's done with that record, you guessed it, it then goes to the second record, grabs the SysID, jumps across to the task SLA table, scans down the task field, sees if it can find the match. It's either zero match or one or more matches. And if there's zero match, this incident is not in our data set. If there's more than one or more, it is inside our data set. We have a tried here, by the way. So if I click try here, this is actually telling me all of the incidences that have actually got. I can actually see more information here. There's only just a very small amount sitting here. All right. So there's actually 2,283 records where the incidences have actually got one or more service level agreements, service level SLAs. Does that sort of sound fair to you? Okay. But wait, we can do more than that. Let me quickly show you something. Okay. Okay, this is where it really starts to show the power of this system. Okay. Now at the moment, if I was to write a report on this and I was to point it to that virtual table / database view, it would show me all of the fields from both the incident table and the SLA table. And the more data you extract from a database tables, the higher the performance hit. So what you can do is you can go into these individual tables and you can select which fields you want to get. Now if this is empty, then it brings back every field. I must bring back that one there for the incident table. That is requirement if I'm going to restrict this. So I will go in there and first of all I'll make sure I bring back the one that I have to bring back. Cool. Now I might only just want to find just a few details about this. Alright, so for instance I might just want to have the number of the incident, so that would be 1. Okay, and I might want to see the short description, so I might do that as well. I'll grab the short description, and I think I might just grab a few more. Okay, I might grab, well, I only want to see the category, and I might grab the priority, and I think that'll be it, just for the to save time. Yeah. Okay, but I had to grab that SysID field, otherwise I'd get an error when I tried to do this. Now I'll update that. Now I can do the same for the task SLA table. In fact, the task SLA table is only bringing back the required field, being task. That was in the where clause. You can see it right here actually. Okay, when we go into incident here, I must have the task. So I've done that. That's all cool. Done that. And I'm bringing back the time zone, the start date, the end date, and the SLA, and that's it. So now when I push try it, okay, when I go to here, there's now a lot less fields available. Unfortunately, it does, however, show you the SysID field twice, because that is actually in both tables. That's the one in the incident table using the prefix, and that's the one in the task SLA table using the prefix. Now this is going to, when the reports go to get written now, this is now a lot less columns that the report writer can see and have to deal with. So the great advantage of doing what I just did is less data will be extracted and only relevant data will be presented to the people writing the reports. You can easily go back later. If they turn around and say, oh, but we need some more data and whatever, you can easily go back and simply redo what you just did a second ago. Whoops, let's go back in there again. Okay, now there's one more I'd like to show you. Okay, and that is, you're going to notice that when I go into the incident table here, there's this thing called a left join here. Now that's not there by default, by the way. If it's not there, just get your administrator or someone with form design permissions to go into your form design here, and they can drag that predefined field onto it. Called a left join. By the way, there is no right join. Now, what does this mean? Well, at the moment, the records that will come back from that where clause will be only the incident records where there is one or more matching task records. You know, SysID to task. If I push left join, then what it will do is it'll bring back all the incidences whether or not there is a related task or not. So therefore I could have a report that shows me here are all my incidences, and here are the ones that don't have SLAs, and here are the ones that do. Whereas if I untick the left join, it will just be a report that says here are all of the incidences of SLAs. Okay. Now, if you want to swap this around, that's exactly what you do. You take that code there and you slap it on the left-hand side, then you put the equal sign, and now the inc sys_id is now on the right-hand side. So a left join is basically can do both jobs, but you simply write your code here in opposite. All right, fair enough. Okay. Okay, so let's see how this will play out. So there is the name of our view there. We'll go and run a report on this in a little while. While we're here though, I'd just like to point out that these can actually be a lot more complicated than this. Okay, this one here is only just got one field, one table, and that's fine. That's fine as well. It's cool. But you can also go in and you could have 2 or more. This one's actually got 3 tables in it. And you can even do a little bit of manipulation of data in here, where you can have less than equal to, less than equal to, greater than, that sort of stuff. And you can put ands and ors in here as well. So you can slightly manipulate the data a little bit before it comes out. So this one here is actually a database view that is actually extracting data from 3 separate tables. Okay, fair enough. So let's see how we use this inside our tool. We'll go down to our data visualizations. We'll go new, and of course how we're going to visualize this. In this case will be a simple list. And now we put the name of the view inside there. The database view. Our system doesn't care if it's a real table or a database view. Doesn't matter. If I now, of course, go in and have a look what's available here, edit my columns, you notice I've only got a very small number that are available there. Okay, which are the ones that I selected earlier on. Okay, fair enough. And then from there, it's just can be treated like any other report. All right, so just to clarify that, if you need to extract data from more than one table and you want the better performance and the capability of doing left joins and right joins, to be able to restrict the fields that come back, which gives you better performance and a better experience for the report writer, and to get better overall read performance, then database views are for you. Thank you very much. Now, by the way, I didn't mention this earlier, but there is advanced learning on all of this on Now Learning. So if any of these recordings that you've been watching and you think you'd like to know more about it, go to ServiceNow Now Learning site, log in and search for advanced reporting. Okay? Why I do these talks, quite simply, is for one reason and one reason only. If you don't know what you don't know, then you don't know what to look to learn. So now you've got, through these recordings, the ability for you to now know what you need to dive into a little bit deeper. Okay? Thank you very much.